Hi gents, I've had to split this one into a second video because that first one was just going on for so long. This is where we stopped off the last time. And there's just a point that I was thinking about in between now and then that I just want to make, and that is to do with this value C that we have here. Okay, so we've got A. We'll go with yellow here. We have A plus B cos C theta. So it's what is multiplying T here. We said that can stretch or compress in a left-right manner. What's happening here? What we should say is our example that we took, which was cos 3 theta. Things that you might get asked, you might get asked what's the period, you might get asked what's the range. Okay, so the range in statistics, you would just take the lowest from the highest, but not in maths. What you would be, or not in, not in these functions here. What you would be saying is the lowest value is 1 and the highest, or minus 1, and the highest value is 1. Lowest value minus 1, highest value 1. Okay, and that's all you do. You just put in those two things there. If it never reaches 1, you would use curve bracket on it, but it does reach both 1 and minus 1, so no need for curve brackets. The period is how often does it take to repeat itself. Okay, so for instance, if we look at our yellow one here, this is 30 degrees and this is 90 degrees, so here's an incorrect reading of it. You could say, oh well, look, it's 0 at 30, it's 0 at 90, therefore it takes 60 to go in there, but that's not true, because it doesn't repeat itself from 30 to 90, because if it did, it would go, okay, maybe I would do it in a slightly different color. If it did, what would be happening was it would be doing that, and if it repeats itself, it would just do that every time, and it doesn't, as we've seen from the thing above it. So instead, what we're looking for is it has to repeat itself entirely. So in our case, it starts off at 1, it goes down to 0, goes down to minus 1, comes back to 0, and comes back to 1, and now it's ready to restart its journey. So actually, if we go from 0 degrees, and this thing here is 120. And the way, of course, that you can get that is, what you're looking for is 360 degrees divided by that number. Now, typically, like I said to you, they won't give it to you in degrees, they will give it to you in radians. So it'll be something like pi over 6 times theta, or they use t quite often. And if you want to know what the period of this function is here, whether it's sine or cos, all you have to do is do the equivalent of 360. So 2 pi divided by pi over 6. Okay, and you can plug out a calculator if you want, or you can just say it's divided by pi over 6, which is to say multiplied by 6 over pi. The pi's will cancel, and there we go. So you will have what the period is. Okay, you'll be able to tell what it is. Okay, we have spent quite a bit of time now teeing this thing up. So what I suggest we do is we just kick on to the actual question that was asked. So let's see, that was, I think I actually had it on this sheet, chat, all the way over here. Okay, right, I'm loath to get rid of that bit on the right, but anyway, we might just zoom in, we'll be able to deal with it. So we'll go back to our green, which we use for the most part. So it says here, the depth of the water in meters at a certain point in a harbor varies with the tide and can be modeled with the function f of t is equal to a plus b cos ct. So just like the thing that we were using there. Okay, very important, a cos model, when you're at 0, so when t is 0, you're going to be at your maximum point. Okay, whereas with sine would start down here at 0, not so when it comes to cos. So it's going to be at its highest point. So importantly here with our axes, okay, our axis is going to be like around there. Okay, you shouldn't have it so that it goes along there. Okay, this would be a sine function as opposed to a cos function, or at least pretty close to it. Okay, we can make this guy a little bit smaller. Right. What does it tell us? The depth of the water in the harbour at high tide was 5.5 meters. Okay. So I will draw this thing in here. Now, the important part is that you have to have your axis, of course, feels partway along here. Okay, but that is not necessarily the case, because what we saw was, for instance, when it came to the red one there, 1 plus cos theta, what we found was it lifted the whole thing up. So it's not the case here that we are definitely going to have the axis all the way along there. So let's just try and work out what we think is going on here. We'll just put in a temporary axis for just a second. Okay, the high tide, we're told, happens at 5.5. And we're also told that the low tide occurs at 1.7. So this gives us a piece of information now. This tells us what is going to be our halfway mark along these two things here. So all we have to do is take 5.5, add it to 1.7, 1.7, and divide by 2. So we're getting the mean of the two things, and that comes in as 3.6. Oops, I beg your pardon, 3.6. Okay, what does that tell us? That tells us, that actually gives us enough information. It tells us, based on what we have over here, for instance, everything here is centered along this line here, apart from the red one, and the red one got shifted up, and you'll see that it's centered along here, along 1, because 1 was added onto it. So what we can already tell here is what was added on to this function, which would otherwise have been, you know, doing this sort of thing. I should actually make that some way accurate. Okay. And it wouldn't have been at 1.7 either. If we are going to be accurate, it would have been at 1 down to -1, 1, -1, and so on. That's what it would have been, except it's all been shifted up, and it's been shifted up by 3.6. That means that we are able to say with certainty now that A is equal to 3.6. Okay, we're sure of that because the whole thing has been moved up. Okay, the other thing to notice is that the gap between there and there, and the gap between there and there, which of course should be the same, if it was just a regular old cos function, that gap would be 1. Okay, but you know, looking at this thing, which one got stretched? The one that got stretched here was the blue one, and it got stretched by a factor of 2. So instead of just being up 1, it was up 2. Everything got multiplied by 2. So if we can just see what is the gap, what is it being stretched by, instead of just being 1, what is it being multiplied by, we will be able to find out what is the B value. So let's go ahead and get that particular B value. Well, the way to get it is just to subtract one from the other. Okay, so it's just going to be 5.5 minus 3.6. And let me just do that. 3.6, that's going to be 1.9. So it's 1.9. So in our case, over here it was being multiplied by 2. In this case, it's being multiplied by the B value. So there's our A value. Our B value is equal to 1.9. Okay, it's been stretched 1.9 in either direction. Okay, it's also 1.9 going down the way. So it's been compressed just like that. Okay, so what we might try to do now is we might actually try to stick in some particular values here. Okay. Give me 1 second. I'll just do them in rather than wasting your time drawing it. It takes a while to draw it. Okay, so what I've done here is I've drawn out the axis here as we go along. 5.5 should be your top. 1.7 should be approximately where the lower portion of the graph is, and it should go up and down between those two things there. It looked to me like we were dealing with 0.5 per box, if you like. Now this one is done, you should always label your axis. This is meters. Okay, and it is depth here. And over here, I've done it as t, which is measured in hours. But I just want to make just an important point here. Like, what is this? This is t equals 0. Now, what did t stand for? T stood for, we'll just read off that. T is the time. Maybe I'll just change that into green. T is the time in hours from the first high tide. Okay, so we are at a high tide up there, clearly, and the high tide occurs at 2 a.m. So you can say T equals 0, which is the equivalent of 0 to 100, okay? Or 2 a.m. if you want to put it like that. So if you wanted to, if you want to do T meaning the local time, okay, 2 a.m. would be right there. And if you wanted to, you could, say that that's 1 a.m. You could say that's midnight. So what you could do is you could draw your y-axis along there, but that would mean that you're not doing it really you're not saying it's t, you're just saying the bottom thing is local time, as opposed to t, which is the number of hours after the first high tide, after 2 a.m. It's the number of hours after 2 a.m. That is what t is. Personally, I would be doing it as, I would be doing like this as t, because those are the two variables that it gave you as. It gave you f of t, or y here, which is your depth, that's your output, and it gave you t, which is the number of hours afterwards. So that's personally what I would put in. You would need to be a little bit careful, for instance. So for instance, if we were going to just like label this time here, it said high tide occurred at 2 a.m. and it occurred at 2:34 p.m. But of course, what we're measuring here, if I write it like this, what we're actually measuring here is the number of hours after the high tide. Okay, so this would actually be 12, and it would be 34 minutes. So if it's done in hours, you would say, 34 over 60. So 34 divided by 60. So that is 12.5666 recurring. Okay, we'll say 567, something like that. Okay, that's what you would have there, and this, of course, would be your the halfway distance between the two things. I did notice that in the answers for the Leaving Cert, I have to say, I'm not particularly happy with what they have here. I think it's poor. I would certainly give out to a student for it. First thing I notice is it's got absolutely no axes whatsoever. Sorry, it has axes, no label on the axes whatsoever. So they should say depth in meters up in the top left, and they should be clear about what they mean on the bottom right here. What they have on the bottom right here is they have the local time. It's not done in terms of t. It's done as local time. So that's quite a different thing to what they necessarily said. It wasn't clear from the question. So I would think both examples are things that are okay to have. What did it say to do? It said use the information to add as accurately as you can, labeled and scaled axes to the diagram below to show the graph of f over a portion of that Saturday. Well, we are showing it over a portion of that Saturday, and we're doing it in terms of t, which is the number of hours after the high tide. So yeah, so I think this was not a well-crafted question, and I think that they could have been a little bit clearer about what they wanted in the whole thing. But look, that's what it is. I also have a problem that they're asking you to do the most difficult thing as the first thing. They've sort of stopped doing that a little bit more. So look, those are just my criticisms. My criticisms of it. Just to be clear, that 12.561 that is t here. So I'm saying that should be in black rather than in green, because it's that many hours after it if we were doing it in terms of t. Okay, look, let's continue on with it. It said find the value of a and b. I'd actually already done that up here. Just a reminder, how did I get a? That's how much it was shifted up from here, like where is the middle portion of it, and it is at 3.6. So 3.6 must have been added onto it. And how do we get what b is? B is the stretching factor. So it is from 3.6 up to 5.5 and also down to 1.7 as well. And it's been stretched by 1.9. Okay, so back to this thing here. It's going to ask us show that c is equal to 0.5 correct to 1 decimal place. Now you'll know that we spoke already about how to get the period of it. So that is the amount of time that it would take to repeat itself. So first thing that we'll do is we'll say what's the range. Okay, just I know this wasn't a question. What's the range? This is the highest value to lowest value. So the range is that it goes from 1.7 up to 5.5. We would write like that. Now remember what we said about the period. The period, the bit that it takes to reset itself, it's equal to this number c divided by 2 pi. Okay, or sorry, 2 pi divided by this number c. I set it upside down. So that is what the period should be. So what we can do is we can actually figure out what is that period, because t, ct, these are always going to be done in terms of radians. In fact, it even says it there, expressed as radians. So what we should do is we should work out what is it going to take to go from one to the other. Well, actually, it's unfortunate. I just wrote something out. It was that we knew here, and I'll put it in black, that this occurred at 12 hours and 34 minutes. And if I can remember, that was 12.567, I think it was. I will just double check it. Yeah, so that's 12.56 seconds. So it's got to all be in. It's got to all be in hours. Okay, so that's how many hours it is afterwards. So now we know what the period is. We know that it goes from 0 to 12.567. That's what the period is equal to 2 pi divided by c. So a tiny bit of algebra here, nothing tough. That many c's is equal to 2 pi, and it should be that 2 pi divided by 12.567 will give us what c is. And in fact, they're kind enough to tell us that after giving us a really, to be honest, poorly laid out one. So 2, I'm going to say times 3.14 because I can't find the button on my calculator. 12.567, and that comes out to be c is equal to, and this is saying 0.499, whatever, to 1 decimal place, 0.5. Sorry. So let me just actually see what you would have got. Sorry, 2 pi divided by 12.5, and it was 666 reoccurring. Yeah, the same thing, 0.49999 or whatever. So there we go. C is equal to that. That's our answer for it. Okay, use the equation F equals A plus B cos CT to find the times on Saturday afternoon. So when we are using our T, we're going to get T equals, and then we have to actually get the time, okay? Because T will be the number of hours after 2 a.m. So we'll just need to take whatever that is and add it on to 2 a.m. When the depth of the water in the harbour was exactly 5.2. Give each correct answer to the nearest minute. Okay, I will get that now and be right. Okay, so here is the function that we found earlier. Y is the depth, T is the time after 2 a.m. as we were saying, and they're giving us here the depth and asking us for the time, albeit that there's a little bit more to it. So it's 3.6 plus 1.9 cos 0.5 t. Okay. So this is going to be 1.6 equals to 1.9 cos 0.5 t. So divide by both sides by 1.9. Okay, divided by 1.9, and then we're going to do cos inverse. Okay, so it'll be 0.5 t is equal to cos inverse 16 over 19. So cos inverse of our answer, and that comes out to be 0.5 t is equal to 0.5699621 blah 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 blah, and we'll multiply both sides by 2. So times 2, t comes out to be 1. I'm going to say 14 here. Okay, so this is how many hours after our peak that 5.2 is going to occur, a depth of 5.2 is going to occur. So if we go back up here to our yoke here, what this is saying is that, 5.2 is, let's just say this here is 5.2. What we've been told is, we've just been told one of the times, if you like, we've been told that it's t is equal to, I've already forgotten, 1.14 I think it was, yeah, there. Okay, so it went from 0 to 1.14. Now, it did ask us, we've got to be a little bit careful here, it did say that afternoon, okay, afternoon, and I don't think 3 a.m. counts as the afternoon unless you're in the middle of lockdown. So it's 5.2 is more going to be alongside here. Yeah. Let's retry that. Okay, so these are the times I think that we are interested in. So remember, from the peak it's 1.14. Okay, from the peak it's 1.14. So from this peak here, we're just going to add on 1.14, and because it's symmetrical, we'll also take away 1.14 as well. So 12.567 plus 1.14. So we're getting here 13.707. So we'll say 71. 12.567 minus 1.14. Our other time that we're getting is 11.427, so we'll say 4.3. Now, just remember here, you know what, I'll keep it as accurate as I can, just in case, because I think it did say to the nearest minute or something like that, so we have to be careful. It's easy to think that this thing is not in the afternoon, because it looks like it's not after 12, but remember, our t is the number of hours after 2 a.m. Okay, so that's after 2 a.m. So we need to add 2 hours onto that in order to get the time, as we also need to add 2 hours onto this one as well to get that time. Okay, so this is obviously 1 and it's almost 1:30, but we'll just get what that is. That's 0.427 of 60 minutes, because I think it wanted it in minutes. So that is 1 hour, and for me that's coming out as 26 minutes. It says 25.62 minutes. When I say 1 hour, I mean 1 p.m. and that, so 1:26 p.m. And for our other one, 0.707 of 60 minutes comes out to be 42 minutes. So this one here, it's like 1500 hours. So this is 40, now it's 42.42. So that's rounding down the 0.4, it's 42.42 minutes. So to the nearest minute, that's what it would be. So 3:42 p.m. Okay, and let's just actually check, what did the question say? It's always handy to know that. Yeah, find the times to the nearest minute, and we've already done that. So that is going to be 1:26 1:26 p.m. and 3:42. Okay, as you can see, that was a really long question. That's why it took two videos. I don't think it was a particularly well structured video. And no, I'm not. Oh, sorry, structured video. Hopefully the video is okay, but it's not a well structured question. And I'm not the only one who thinks along those lines. I think that could have been asked better, especially considering that T could have been different places. So there you see it. 1:26 p.m. and 3:42, which I think is what we got. Yeah. Okay. So that's our answer there. What I would suggest here that you do, I've just got functions open on StudyClicks, but obviously you can get this on examinations.ie. But if you go into functions, you can find all of these in there. And if you are looking to try these out, and you can see that they are tough questions, and they come up frequently, so this is something I would definitely want to know. Just flicking through it, I see there you've got 2019. That's going to be paper 1, I'm sure, and it's question 8. If it's not paper 1, it's obviously paper 2. So if you can't find it, it's there. Have a little look at that one. Give that one a shot. I would say it's a long question as well. That's another reason to do it, because we didn't get to do so many of those ones. So that's a smart goal, I think, to do that one. Do we want this one here? It's not so much the same, but obviously give it a shot if you want to. That was 2018 question 3. I'm not sure which paper that one is. No, that one's not really like it, even though it's a long question. Either that one or that one. There are a few lurking out there. So this one was the one that we've just done. That was 2017. And you know what? I'd practice it even after you've seen me do it out there. I would do that again because it's tough. Now there was one. Yeah, that's the one I was looking for. 2015 question 9 here. So this is to do with the length of a day from there and there. So very similar to the one that we've had. I would give that one a shot. I think that's the earliest version of those types of questions. So if you want to do those two, the 2019 one and the 2015 one, and then if you've got problems with that, either of those, and you would like me to do them out, just drop me a mail like everyone else has, and I'll happily do them. Okay, gents, take care. All the best.